Hello, friend. My name is Derek Carter, and welcome to this video. This video I'm making in order to show people how to access and use their Slurm accounts on the Line Cloud or the TLC Slurm cluster compute machine. So I'm making this for my 560 neural networks and deep learning class, but it might be used also in general for other classes, or if you're a graduate student and I've been talking, you've been given access to the TLC Slurm account. So real quickly, in this video I'm going to cover a couple of things. So we'll go over basic how you get into your Slurm account, so using secure shell SSH key authentication, a little bit about using just basic Linux commands, and also SSH to copy files over and get things set up, so you can use git commands to get files to and from, or else use SCP to copy files to and from your Slurm account. But then specifically also, one goal of this video is I want to show you how to set up and access the GPU resources on the Slurm compute cluster. Okay, so with that, let's go ahead and get going. Okay, so the first thing we'll look at is just basically how you access your account. So I assume in this before starting this video that you've gotten a account set up for you on the TLC Slurm system, and you've been given a secure shell private key that you can use to access your account. You also need to already have secure shell client installed in your system. So if you're on Windows, you might not have that already, so you have to go and find secure shell and install it first. I'll give a link in the video to another set of instructions that I usually give for classes for setting up accounts, which includes setting up a secure shell key so you can use with GitHub. So let's start with so I'm going to do quite a bit of stuff in this video, doing stuff from the command line. So I've already got here my key. So you should have gotten this in an email. So this is a private key. I won't show you what's in here. You should treat a secure shell private key as if it's basically a password. Okay, so it's like a password in a file, although it's not easily rememberable like a common password would be. But still, if somebody had this file, they would be able to log into your account. Okay, so if you have your key, you can use a secure shell key authentication to access your account. You also have to have a secure shell client, as I already mentioned. Okay, so if you have your key file, then basically you need this information in order to log in using secure shell. So from the command line, you can use the secure shell client, and we're going to specify that I'm going to use this file as my identity. Okay, so this is basically my password that I'm going to be logging into with on my account. We're using a non-standard port usually in order currently to log in, access your Slurm account on the TLC cluster. So this is the port we're using right now. I should have given this to you as information that you need to authenticate. The port number might be different, so check with the email you got with the information. You also need to know your username. I'm using a username SLU for Slurm user right here, right now, and again, this might change, but right now the name of the machine is slurm.eatamu.pro here. Okay, so this should allow you to have basic access. So this is secure shell in. You won't need a password. This is all the password you need, is the private key here. And this will do private key authentication and get you into your Slurm account. Okay. So when you're ready to log out, just use exit, or you can use Control-D. So I recommend, instead of kind of remembering that, typing that out all the time, to use what are known as secure shell config files. Okay. So So I'm actually working on a Linux system, but this should work on a Mac or a Windows system the same way. So in your home directory, there should be a directory called .ssh. Right? So this holds things related to SSH. I usually put my keys in there, but it also can hold a config file. So I'll just use a command line tool. I'll use the Nano editor here since I'm going to use this again on a remote system. You could just use in VS Code or whatever your editor is, just Notepad or something on your system to edit the config file. So here, if we want to make it a lot easier to use like a secure shell key, we want to add an entry. So I'm going to call this Slurm. So I'll be able to, from the command line, use Slurm as a shorthand for accessing the Slurm cluster, my account here. So then you basically need all that other information. So the actual host name is slurm.etamu.pro. We're using a non-standard port, so if you're using a standard port, you have to specify the port number in the config file. But if you want to go to somewhere other than the standard secure shell port, you can specify the port. The username we're going to connect with, the identity. So the tilde means look in my home directory, and in the home directory there's a .ssh subdirectory. So I'm going to actually move my key to here, right? So you can specify the path anywhere, but I usually put all my keys in that .ssh directory since that's used by the SSH client anyway to hold keys. Okay, so and you want to say to only use secure shell key identity, so don't use password authentication. All right. So here, that's all I need in my config file. So I'll go ahead and write that out. And like I said, I'm going to move my key to the SSH directory. Okay. So now I should have my key in the SSH directory where I specified it in the config. So now, once you set that up, instead of typing in all that information each time, I should be able to just secure shell directory to Slurm. It'll look up in the config all the information, the username, stuff like that. And this should directly get me into my Slurm account. Okay, so now that we're in our Slurm account, I'm going to talk a little bit in general about setting some things up. So it would be good to know basic Unix, Linux command line tools. So this is a Unix, this is a Linux command line here. You can edit files locally using like Nano or VI or Emacs if you have those. If you don't, you actually can access using the VS Code secure shell remote access. So in my classes, we're often using Docker dev containers. So you do. I'll show that real quickly here, but you can access that. The thing is, we need to get files to and from your Slurm account. One way to do that is you can just set up Git and do Git clones and do Git commits and push commits to and from a repository. But I'll also show real quickly using the SCP copy tool here to get files to and from your Slurm account. Okay, so first of all, let's set up GitHub. So I'm going to open up another terminal. So I'm logged into remotely to my Slurm account here, but I want to copy my GitHub key and reuse it. Okay, so you could just generate a new GitHub key and add it to your GitHub account. So there's pros and cons of either using a different key for every place that you want to authenticate from or reusing the same key. I'm going to show reusing the same key here. So for example, if I want to copy files from my local machine onto Slurm and I've got SSH set up, I can copy my GitHub key from my home directory. Okay, so this is the one I normally use for GitHub authentication. And since I've got Slurm set up in my config file, I can just very easily specify that the destination is going to be Slurm. Put it into my home directory. I'm going to put it into the SSH subdirectory like that. All right, so this should copy the file from my local machine up to my Slurm account. Okay. So now if I go back to my Slurm account and look in the SSH directory, you'll see that we have the GitHub key here. All right. And I'm going to set up a GitHub configuration config file so that I can easily use my GitHub key here. So again, here, I mean, like I said, you can use VS Code. I need, if I want to use an editor on the remote system, I need to use a terminal-based editor, so like VI or Emacs, or the Nano editor is another real simple one that is usually available on systems like this. So I'll just continue using Nano here real quickly as an example. So again, I'm going to create a config file in my .ssh directory on the Slurm system here for my GitHub key. So, I mean, this is the name. Again, this is the name that I'm going to be using locally, but I just left it as github.com, the same as the actual host name that will get used. And the only other thing I need is to specify the key that I want to authenticate GitHub with, okay? So I'll go ahead and write that out. So now that I've got that in my SSH, and I know this is a valid GitHub key, so you already have had to set up your GitHub key so that you can authenticate with it. I can test that I can authenticate here. So if I SSH to git at github.com, you don't want to add the user here because we're not normally using git user. We're using a different user. But this will check whether my secure shell key can authenticate on GitHub or not. Right. So if you get the successfully authenticated, you know that you've now got your SSH key that'll allow you to do git clones using SSH URLs and git commits and push back work. Right. So that's how I do a lot of getting files to and from like a Slurm cluster is just through using git and pushing to and from a remote repository, having set up my git key correctly. Okay, you should do some other you should do the normal git configuration here as well. So I need at least to have my name set, and my email, like that. So that's usually the only basic ones you need. There might be other stuff you want to configure, but so right now I've just got my username and my user email set. Okay. So with those, so with Git authentication set up, I'm just going to use as an example for the class that I'm working on right now. We recently completed this assignment 2. So I've got my own solution for the assignment 2 here. So, you know, I would normally use the SSH URL to clone here. So let me just go ahead and copy that and show a git clone. So here from the command line. So I like to usually put my repositories in a repo subdirectory. So now I've got a repos here subdirectory. So from command line, you can do the normal git command line commands like git clone, git commit, git push, things like that. And I'll use paste to paste in that URL in order to clone down, you know, get a copy of my assignment 2 solution. All right. So now I got all my assignment 2 files repository here. I'm going to be using this as my example for setting up GPU projects and things like that. Okay. So as a final one or two things in this section here. So another example of copy file. So if I wanted to copy a file back from my Slurm account back to my local system, let me just make a file here like I use Nano again. So I'll create a file here. I'll write it out. I forgot to write it out before I quit last time. So Control O to write, and then Control X to exit here. And so, if I wanted to get that file down, so I'm back, I'm using tabs here on the terminal here, so I'm back on my local machine here. So if I want to copy like a file from remotely, it's the same kind of thing. So take the source is on Slurm. And I'll copy it over to my temp subdirectory to the file called test.txt. Or just another example. So I might I want another file up on the Slurm cluster to use here in this example. So I've got a notebook called GPU test. So if I wanted to get this up there so I can use it, so I'll copy the GPU test file up to Slurm. I'll just copy it up to my repos subdirectory. I can't remember the name here. So this should copy it up to my repos subdirectory. So if I go back to Slurm, I have it in here. So I actually really want to put this though into the assignment 2. So I'll copy that up into the assignment 2 notebooks subdirectory then. All right, so that was just some examples of copying files to and from. One other quick note before I leave this section, that if you're using the dev containers in our classes in order to run assignments inside Docker dev containers, if you installed also like the remote SSH tool, you can do the same thing to do remote development over an SSH connection, which I find pretty useful, if you're a VS Code user. So in particular, if you go to the Remote Explorer and you look on remote titles, you have to have the SSH, remote SSH extension installed. But this should pick it up from your config file, right? So now you see that I have a Slurm here. So if I connect to that in my terminal window, it should actually connect up to Slurm here, and I can now open up like a folder, let's say the repos assignment 2 over here on Slurm. I'm going to go ahead and trust that. Right? Might take a little while to set up things, but so this is another possibility. So in particular, I'm actually editing files here in VS Code, but they're being edited over that secure shell connection. So I can do all my work, even though in VS Code on my local machine on the secure shell connection. All right. Okay, so now that we've covered basic how to get into your Slurm account and basic setup in order to get files to and from the Slurm account and maybe edit files on there, config files and things, I'm going to show, we're starting on this section to look at how you actually use the GPU resources. So setting up some things so you can actually use GPU resources using Python, Python scientific computing stack, basically TensorFlow and Keras, or maybe PyTorch and TensorFlow or something like that. So we're using a batching system known as Slurm. So that's the name of our cluster. These kinds of batching systems are common for high-performance computing clusters. Other ones might be using something slightly different than Slurm, but they all have the same kind of a concept. So, real quickly, let me just mention some of the basic commands that we'd use on Slurm. I'll put a link to this website into the video down below here, among the other information about the video. There's other examples on here, including maybe some links to more comprehensive tutorials on using Slurm. So in particular, you'll mostly be using the sinfo, the sq, and the sbatch and the srun commands when you're doing stuff on Slurm. So so let me real quickly just show those commands I just mentioned. So you can get basic information about the queues on the Slurm batching system or a similar batching system using something like sinfo. So we've actually got 3 different types of queues: the debug queue, the CPU queue, and the GPU queue on this system. You can see what's currently running by using sq. There's nothing currently running right now, and I'm making this video here. And you use sbatch and srun in order to actually submit jobs. Okay, so for reasons I'll explain in a bit here, I'm going to actually do an srun. So we use srun to actually create an interactive session where we're allocating some resources on the cluster. So in this case, I want to get one resource, one GPU resource, so I can use a GPU on the cluster here. So I want to be allocated a GPU resource, and by doing srun, we're going to say we want a bash session. Right, so I'm just going to use a bash command line. Okay, so this will actually queue up and allocate a resource. So by default, this will run on the debug queue here. So we'll have at most 8 hours in order to do our work if we use the default debug queue here. That's what the time limit means on these different queues that we have. Right, so if I do that, I should get allocated we've only got one node currently that has GPU resources, the GPU 1-01. So you notice that I'm on GPU 1-01, and if we look at queue, you'll see that we've now got one thing running, which is this interactive job, and we've been allocated a GPU at this point. So if you look at CUDA visible devices, so this is an environment variable. So I should have been allocated. So normally this will be unset, but if it's set, that means if I run TensorFlow or other kinds of similar Python packages, it will only have the 0 GPU. There's 5 GPUs available on this machine when I'm making this video here, and we were allocated the first one, which has an index of 0. Okay, so in order to use the GPU effectively, we have to set up, we're going to show setting up a Python scientific stack that you can use TensorFlow and Keras on. Because of the age of our hardware, we really have to use Conda instead of basic pip virtual and Python virtual environments, because Conda will actually do the right things in order to recompile the TensorFlow packages to use older hardware. So you might be able to just on a more modern environment just use basic Python stuff. Although also, if you ever do access like a big high-performance compute cluster, they will actually have other mechanisms set up so you can have standard packages available for doing like Python scientific stack for these kinds of things. But I'm going to show creating a Python environment using Conda Package Manager to install the package we need for the assignment that I'm using as an example, and also set up our Python path. So I do recommend creating an environment for each assignment that you do and having the packages that you need in those assignments. So if you're doing my 560 class or a lot of my classes, there is a file called devcontainer, which will usually have a requirements.txt or an environment.yaml file. So for this assignment, we were actually using basic pip package management, and these were the packages that we specified as being required for the assignment. So Conda uses the environment.yaml file for the same kind of thing, specify the packages that you need. So we're going to create a Conda environment. So we'll do that first. So you should have on our Slurm cluster, we've already got the Conda package manager, and it should be in your path, so you should be able to find it. So I recommend creating environments like this currently. So to create a new Python environment, we do a conda create. I'm going to create it using in my local directory. Okay, so I'm going to create it in a subdirectory called environment. So you can create conda environments to be used over the whole account, but I'm going to have one specific for each one of, so this is going to be in a subdirectory called environment inside of assignment 2 solutions, so I can put exactly the packages I need. And also, you might not normally have to do this, but it turns out that Python 3.14 just came out, but it looks like the TensorFlow package hasn't been updated to work on 1.14, so I have to go back to using 3.13. Let's go to, so this will actually create a subdirectory called environment, and inside of there, we're going to be putting all of the files for all of the packages that we need, although we're not initially installing anything on there. So the next step I'm going to do is actually activate that environment and install the packages in there. Okay, so each one of these steps I'm doing here might take a little bit of time. So, by asking for Python 3.13, it installs Python and a few other basic packages like pip and some other things that it needs. It shouldn't take too long to do the first one, to create the environment and install the basic packages that are needed. So we'll go ahead and pause there while this is completing the transaction. So once it's done doing the initial creating of the environment, like it says here, you have to activate the environment. Okay, so right now, I'm actually using an environment in the conda, so the base environment in conda is what I'm using. So I can tell that if I use the which Python to see which Python interpreter I get. Okay, so when you do an activate, so like it says here, you can do an activate of the full path. Since I have my environment is local to the assignment 2 subdirectory, or you can just do a conda activate using a relative path, so it's in the environment directory relative to my current directory, /environment. Okay. So notice, so this is typical when you're using virtual environments in Python. It modifies your path to give you a hint of which environment you're using, but it's also often it's a good idea to be sure. So if I do which now, I should see that it's picking up the Python from my virtual environment, from the conda environment that I just activated. And then I can check that we did actually get a Python 3.13. So we're getting Python 3.13 that we're using here if I run Python. All right. So once we did that, I actually don't have everything I need in order to run this assignment in here. So again, if I look at that requirements that I set up for this assignment, I need all those. So I can just install these by hand. I could set up my own environment.yaml file and use that to update the environment. I'll just go ahead and install these by hand. So I'm going to do a conda install. You don't really need to install the wheel, but everything else, including, don't forget, you need the TensorFlow and CUDA. So if you want to use the GPU resources, you need this one here that's commented out in the original requirements.txt file. So I want NumPy, pandas, matplotlib. Probably don't need Seaborn, but learn h5py. If we want to run IPython notebooks, we'll need these as well, the Jupyter and the JupyterLab and IPyKernel. Jupyter, JupyterLab, and TensorFlow with the CUDA for the GPU support. Okay, so if you make a typo here, it's good to know kind of your command line stuff. So if I use up arrow, I can get the command back, and I can use back and forth arrows and Control A, Control E to move around and edit that. I did actually have another typo, so it should be conda install all those packages. Okay. So assuming I didn't make any more typos, and that's all right. You might have to accept some terms of services the first time you do this, but again, it's going to install these into my active environment. Okay, so it's going to install a bunch of stuff, but it should be installing TensorFlow. We need to be on the GPU when it does this, so that it recognizes that CUDA is installed on the GPU, and it will try and install TensorFlow correctly with CUDA GPU support and CUDNN. Okay, so yeah, you do want to see these CUDA and CUDNN, as well as, you should see TensorFlow and the Jupyter and other stuff on there. Right, so this is all going to get installed into my environment, and this might take a while. There was more stuff that's going to be installed here than I installed when I was initially creating the environment. So I'm going to go ahead and pause again there while this is completing. Okay, so once Conda finishes installing the packages, you might want to check out that you can access like TensorFlow and stuff like that. You could always go into Python. So remember, if you're in the environment, you should find that the path to the Python you're using is in the environment that we just created. And I should be able to import any of those packages like TensorFlow in here. And we could run the commands to, for example, see which devices are visible. So the first time it does this, it might take a pause a little bit in order to do some additional setup for TensorFlow here. All right, so we should be able to import, and like I was saying, I would probably normally have exactly what I was looking for. I went and updated it a bit. So for a lot of the assignments, I added in some stuff to import TensorFlow and actually to do these things. So this is a good thing to check if you want to use GPU, that it can actually see the devices. So TensorFlow can see the devices here. So if we have those in, it should, what you want to see is that we have both a CPU and a GPU device available when it gets to this part here to query these and display what devices are available. So there on the available devices and the logical devices, we should see physical devices. A lot of messages came out here, so it's a little tough to see. But yeah, so you can see the available devices. We have both CPU, but the important thing is that we're able to see the GPU device here as well. So, oh yeah, there was the physical device message I was looking for, just inside of all these warning messages. So you'll get a lot of these often, especially on the older hardware, but usually most of these we can turn off or ignore warning messages from TensorFlow here. Okay, so one other thing here. So for assignments for a class, often you need to have the Python path set. So I would normally set this up in my bash RC, set up this environment variable. If I was just using basic Python virtual environments, that's a kind of a pain because every time you want to switch to a different virtual environment, you have to remember to update the Python path. So Conda actually does have a nice feature for this. Since we're using Conda anyway, I often recommend using this feature. So if we want to use this feature in Conda Package Manager, you can actually also associate environment variables with the Conda Package Manager. We would normally do this, put into your bash RC to set like the Python path, but that's problematic because if I want to change to a different Python environment, I have to remember to set that by hand. So it doesn't, when you're using bash RC to set environment variables, it doesn't automatically change them. So in this case, we'll use this feature. So I don't think you can do this with basic pip and Python virtual environments, but kind of allows you to associate environment variables in its config, so that when you activate a Conda environment, it will also set the environment variables just like this. So you do this command, conda environment config var set Python path, and then I'm going to set a absolute path here, just so I don't have to worry about if I'm in the right directory when I run stuff. So from my home directory, we want our Python path to be to repos, assign it to solution. Sorry, you shouldn't normally get that error message. Let me try that again. So so assignment to solutions. Solution slash source. So you have to be careful to get everything right. So it should be tilde for my home directory, like repos, to solutions for source. So like I said, it should actually immediately take effect, but you might want to, like it says, maybe deactivate and reactivate here. Let's, oops. So let's show activating and deactivating our environment here. So if I want to deactivate, simply kind of deactivate. So now we're no longer using that environment we set up. We're back to using the base environment. If we look at Python, we set up. It'll be using the base one from Conda. And if we look at our Python path, I'm not certain if this will get deset or not. So yeah, it's no longer set. And if we reactivate this environment that we set up to use the TensorFlow and GPU, it should now have the Python path set up. Also, we should have the CUDA visible devices set up. This was set up by Slurm from the srun command. Okay, so we should be all set now to actually run notebooks or Python code using TensorFlow and Keras and other stuff here. So I kind of mentioned in passing why we're using kind of packaging manager right now. So on other kinds of Slurm clusters, they might already have the stuff set up for you, but often you do need to set up your own Python environments. There would be instructions for how to do that. You can sometimes just use basic Python virtual environments. We have some older hardware here that's where using the Conda package manager makes it easier to correctly set up TensorFlow when we create the environment to use our GPUs. So that's basically why I'm showing you using Conda in this environment here. Yeah, that was the answer to both of these. So and this doesn't quite work correctly unless you do the install on a node that has the GPUs visible, because then it correctly builds or rebuilds TensorFlow to use the CUDA and the other stuff that you need. So you do need to first be on the GPU node before you do this kind of install, right? Again, a lot of this stuff is not necessarily what you would always have to do. And also on other clusters, they might already have an environment set up for you, so you wouldn't even have to create your own environment. Okay, so our final thing, we'll show actually running some notebooks. So running JupyterLab interactively from the Slurm GPU instance that we're running, and how to set up a SSH tunnel so that you can look at these notebooks in a, look at the JupyterLab running in a browser, okay? So if you're using the assignments from my class, one of the things, if you're using the Docker dev containers, there's a .json file which does some stuff in the dev containers. So one of the last things that it normally does is this post start command, where it creates a JupyterLab server running inside of the container and serving it on port 8888. So we're basically going to be doing the same thing. All right, and I do recommend using these so that you disable using passwords or a token, so you don't have to have any problem signing in. But you need to have this port number. So this is actually going to be opening up a port on the Slurm GPU machine. Okay, so that wouldn't normally be accessible. So we're going to have to create a tunnel from your local machine to this port, so you can see this and actually run a web browser to access the Jupyter Lab. Okay, but there's no real thing set up in order to ensure that this port is available. Here, if you're using Slurm or a batching system on other systems, you might have to do similar things, although some high-performance cluster computers also have mechanisms in place for you to be able to allocate a port for your use, or ports for your use, like I'm showing here. But there are tools like netstat or SS. SS stands for the like socket, system sockets or something like that. Yeah, netstat is an older one. You may or may not have netstat available anymore on Linux system. So if you do an SS-L, it shows kind of all open sockets and all open ports. So in particular, I might look through that to see if anybody currently has port 8888 open or not, right? So if they do have port 888 open, you might have to select another one. I'm going to continue to use the port 8888 here, right? I'm just going to use port 8883. You actually need this port open here. You also need it open on the Slurm manager node. So when you first log in, you're not logged into one of the compute nodes. You're logged into the Slurm manager. But we need to tunnel from your system. So I'm going to show this in a second here, but from your local system to the Slurm manager, and then ultimately to the GPU node that you're running your notebook on. But let's first start a notebook. I'll just use that same command there. Just copy and paste that. The only thing I'll add is when I'm running it like this, I might add in the no browser, so it doesn't attempt to try and find a browser and open up a page when you run it here, right? But by installing Jupyter in our environment, we should be able to run Jupyter Lab like this, and it's going to open up Jupyter Lab locally on the port 8888, okay? And by doing these here, we won't need a password or a token to authenticate into it, right? So we should see the Jupyter Lab running here. So now it's actually has the port open on the GPU machine, port 8888 /lab, waiting for a browser to connect to it. Okay. So this terminal I have open here on the Slurm GPU node, worker node, is busy now. It's got Jupyter Lab running. I need to actually create a tunnel to that port here. So this is a little bit complicated, but back on my host system, I want a secure shell command to create a tunnel. So you need both. You need 2-T options. That looks a bit strange, but this means I'm creating a tunnel and then another tunnel. So this first one says that I have a tunnel from my localhost, port 8888 on my localhost. I need to open up a port 8888 on Slurm. Okay. So by the way, again, I might want to check if anything's running on 8888 or not. There is something running on 8888 locally here. Oh, I know what that is. So yeah, I don't want to use 8888, so I'm going to pick something else locally here. Another thing I'll mention is I've got like a firewall running. Like if you're running Windows or Mac, you might have a firewall. You might have to either turn it off or learn how to allow a port to be open here. So if I want to use a different port, I'm going to have to do something else. I'm going to have to open up so here I'm just going to add 8889 so I don't have problems with conflicting port numbers here. So now if I look for 8889, I shouldn't have anything running on that, right? So I'm going to try using 8889. But I'm going to leave 8888. So this 8888 port needs to be available on the Slurm manager. So let's just real quickly show that, right? So I'm going to open up yet a third terminal here. So here's where, having your config set up for Secure Shell makes it, I don't have to do a lot of typing here. So when you first log into Slurm, I didn't mention this before, you're on the Slurm or the Slurm manager, right? But we're going to have to actually have a tunnel that goes first through here and then from here to the GPU node where we're running the Jupyter Lab on. So let's see. So I don't think anything currently has the port 8888 open right here. So it should be good. So let's try it out. So we're going to 8889 on my machine to the 888 on the Slurm manager, and then from there we need to do another SSH. So this command is going to be run on the Slurm manager, where it's going to create another tunnel from the 8888 on the Slurm manager to the port 8888 on the GPU machine, right? Which currently should have my Jupyter Lab open and running. Okay, so this is a little bit complex, so we'll see if this works or not. So when it does that, it actually is going to log me into the manager and then log me into GPU 1. So I've actually got another terminal running GPU 1, but I should have a tunnel running now from my local machine port 889 through here to the Jupyter Lab. So let's try that out. So I'll just open up a browser. So, we could use that link that I was showing before, but I'll just type it out. So I'm here. I want to go to port 8889 and then go to /lab. So yeah, I think it's working. So if everything's good, I should be able to open up Jupyter Lab, and we'll see that you have your normal Jupyter Lab environment. So I'm actually running the assignment 2, right? So let's try it out. So I'll open up my assignment 2 notebook. So again, this is being run on the Jupyter Lab, and because we set up the environment and set up like the Python path, this should all work because we ran. Let me switch back over. So when I ran Jupyter Lab here, we already had the environment we needed that was active, right? So it should be using the Python and the kernel from that environment that we installed to use the GPU, right? So that should allow me to, if I go back to my Jupyter Lab that's running in my browser, we should be able to successfully run this notebook, right? Including you'll be able to import these things because we've got the Python path set, and you should run everything in here cleanly. This is a solution. I don't think I'm giving away anything here. Most of the real work is going to be in the assignment tasks here, but this is kind of just I picked assignment 2 here just to check that everything runs here, right, on the system. Okay. And we can also try, and remember I copied over that GPU test. If you want to, you can check, compare this to your own system or not. We should have NVIDIA SMI should be available. Let me switch back over and show. So here was the one for our link. So I'm back on my GPU node. So we should see some GPU and NVIDIA stuff is set up. If I run that, I can see all 5 GPUs, although I'm only using GPU 0. Also, you might find NVTop useful. That's installed on our GPU, on the TLC Slurm. So this will give me some idea of what activity is currently running on the GPUs that are visible on the Slurm, the TLC Slurm here. Okay. So if I go back to my notebook, so we had access to NVIDIA SMI. We should see that I can see the CPU and the GPU device. And I'll skip over running the, I started fitting. I might have something misconfigured, so normally the CPU shouldn't take this long here. So right now, running this example notebook takes quite a bit of time running it on the CPU. Usually should only take a minute or two, I think. Your mileage may vary depending on what system you have. But yeah, you'll see that if we run it on GPU, it runs quite a bit faster. So I'll go ahead and just skip over and run. So here is, we're telling TensorFlow to use the GPU device. So it only takes 8 or so seconds. If we go back over and look, so notice, using NVTop, I can see now that it is using GPU 0. So we can see it's not using all the full capacity of GPU 0, using 25% or so. But you can see that it runs much faster than the CPU, right? And on mine, these GPUs are pretty aged, so it takes only a second or less on like a GTX 5000 series. But still, you might find this better than your own CPU. If you don't have a GPU, you might find this better using these old GTX 1080s, even than the CPU that you have on your system. Okay, so with that, I think we covered everything that I wanted to in this video here. So, just to summarize, in this video, we looked at basic setting up, getting basic access using your secure shell key and configuring secure shell. Once you're on your Slurm account, we looked at setting up a get key and how you get files to and from the system using SCP, so secure shell copy. Then we looked up setting a Python and virtual environment using the Conda package manager, what you need to do specifically for our Slurm cluster to use the GPUs that we have right now on our Slurm. And then finally, we showed using like Jupyter Lab and setting up a tunnel so you could actually run Jupyter Lab from a web browser and connect through a tunnel to your Jupyter Lab instance that's running on the Slurm cluster. Okay, so I hope you find that useful, and let me know if you have any questions or things, and that's it for this video.